Hello, welcome back to our tutorial section. Long time no see. So for today, we're going to continue something related to optical flows, and also going to use optical flow as a mechanism for interaction design. But for the interactive part, so in this version, so I try to have a number of tutorials later as well to test using, for example, like something we call render pick, by using initially I think in most of the application they will use a mouse to select objects from a 3D render display through the render TOP, and then we're trying to see whether we can integrate the optical flow selection in order to replace the mouse click for some simple effect. So let's have a look at what you will expect for this exercise. Okay, so this is the rotating board. Actually you can see the interaction that if I use something to interact with the ball, and normally they would trigger by the optical flow detection of each of the location that I use my movement to make it bigger and then resume to the original size. So that is what we are going to do now. Okay, so let me remove everything except the video. Okay, so actually I do not need to use the flip for this one, so we now start with this empty project. So the first thing we're going to do is to, for example, reduce the size of the video to have a better performance for the optical flow, for example. And I may use like half of the original resolution. So after we detect using the optical flow, I may also further reduce the resolution such that we can have less computation inside the script work that we are going to do. Okay, the optical flow, as before, we find it from the palette browser, and then we send over here, and as I mentioned, I will further reduce the resolution. Then we can probably zoom in to have a look. So the resolution I'll try to have is 1/10 of the original resolution of the video capture. And then if we turn on the viewer display, that you can also see the images. So I can also use the nearer pixel to make it like the pixel display. So this is the thing we have. So this is the optical flow of the two channel, red and green. So the other thing that we would like to make use of from the optical flow information is I try to use it to pretend to be a mouse. So in that case, for a mouse you only have one single point. So in later tutorial we can further discuss if we have multiple points that we can implement multiple touch in the interaction. So for this exercise we try to use one single point of interaction. So in that case, if you zoom in to have a look, so what we would like to do is to probably find the brightest area, so the brightest spot in this case, in order to use it as a location of the mouse that with the most exciting movement in front of your camera. Okay, so how we're going to find the brightness? So we can find something like the magnitude, which is the square root of the sum of the square of the red and green channels. The red channel is the horizontal movement, green channel is the vertical movement. So let's do the computation in top by using maps. So the channel pre-operation is take the square of the two channels and then combine the channel by add. But instead of using the 4 channel, we only use the 2 and then just produce this single channel output at the number. And then we can also just choose monochrome 32-bit to have this. So if we zoom in and then use the mirror pixel, so that is the computation. And then the next step is we actually can make it more precise by doing a square root. So I only have the red channel, so I just do the square root of the red channel. Okay, monochrome 32-bit. So if you want to see the pixel value, then you can also turn on the viewer actives and then right click to display the pixel value of different locations. So you can try to move around to have a look. Okay, so that is the value, and you can put it in a node, call it magnitude or brightness. So the next thing we would like to do is to find out the brightness one. So you can have 2 options. One, you can convert it into number and then to use the analyze or different types of chops to find out the brightest area. And alternatively, you can also use the Python script. So I use the Python script to simplify the computation. So with this one, as before, I already written the script in a separate file, and then just do copy and paste to save time, and then I will go through the script one by one, line by line later. So that is all the script here, and then we need to perform the setup to have 2 parameter input. One is the brightness, which is exactly the magnitude that we drop it here, and the other is a threshold that we're going to compute a number and then to see which level you would like to consider is the most click. So the logic of this one will be, we're going through this one. 2 parameters here, one is the brightness and the other is the threshold. And then we're going to produce 3 channels. So why we're going to use this name of the channel, we'll explain later in a random pick, because we have to use the U and V for the location of the mouse, and then select will be 0 to 1 or true or false, and to indicate whether this mouse click or not. So first of all, we got the input pixel value. So I use the 8-bit one in this case and convert everything into grayscale. There's only one single channel. And I also make use of quite a lot of the numpy function. So one is the argument max, that means to find out the index of the pixel would have the brightest value. That's the maximum argument. And the maximum value is in mx, so I also keep a threshold that is the slider around here, so it's indicated with 0 and 256 and somewhere in between. And if the value is small, that the brightness is smaller than the threshold, that will be no selection. So I just give -1 for the UV channel. And just in case the value, the maximum brightness value, for example, I can use 0.2 for initial testing, larger than the 0.2 multiplied by 256, so that we'll have the bright value, and we get the brightest area, that's 1 pixel, and then convert it index into the coordinates of, and put it in index. So the 0 is the y1, and then the 1 is the x1, and that is normalized to 1 by dividing the shape of the image. And then 2, that means we have a selection, and those value we are going to make use of. So this is the thing. So if you increase this one, so there will be fewer interactions. So if you lower this one, so the testing in the light thing of my room may be 0.2 will be okay. So that cross will not be significant because it was caused by the initial error when this one is empty. So that's the none type. Okay, so the next step is we're going to prepare a number of objects that we can interact with. So I'm going to use 3D ball as a sphere, and then I make a transformation to make it a little bit smaller first, and then connect it to a geometry with light and camera. And then the important part will be we have a render that we're going to do render pick in the later section. So I also add the material of 3D one as form. And if you want to, you can also add like texture later. So what we are going to do is to multiply the number of the geometry by using instancing here. And if you take a look at the lighting condition, the lighting is somewhere over there. So if you want to, you can also modify the lighting position to make it somewhere in the top. In the ceiling, I think the negative X direction for the lighting. Okay, and then we go back to the instancing. So instancing here, yeah. So there are two things we're going to modify the instant. One is the translate, that's the arrangement of the different number of balls, and then the other is the size to make it bigger and smaller in the scales around here. Okay, so the arrangement of the location, I use another SOP. So I use a circle probably, And then I would like to arrange all the ball along the perimeter, that's the boundary of the circle, so I don't need to have so many, so I use 5 in my example. And then this one I will connect to a null here and call it position, and drag it to translate to use P0, P1 and P2. P2 is irrelevant because it's still in one 2D plane at this moment, so the ball seems to be quite big in this case, and you can make it smaller. Okay, and the other thing you can also play around with is to overlay your final image from your video and also your rendered image with the ball, and put your video underneath the 5 ball. So that is something we would like to play around with. And then if you want to, you can move away your camera to make them smaller. A little bit too much. Okay. Color. Yes. So if you want to change the color of the ball, then you can also use, for example, a red to make just 5 of them. That is 5 pixels. And depending what color you want to have. Okay, and then maybe okay, so I put it in a null and name it as color. And if you want to, you can also use nearer pixel. Actually, you will see all the 5 color combination, and this go to instancing here with your RGB and animation. So if you want to animate that, like the rotation I use in the exercise, you can use a bit and then to analyze. So I can get back to it later when we sort out the interaction first. Okay, how we will enable the interaction? Actually, we make use of this chops, and then we are going to use render pick in the chop. There's actually 2 locations. One is in DAT that we'll probably cover later when we deal with the multi-touch. So for this one, the easier one, we choose render pick here. And with the parameter, so we're going to have always, and then the most important thing is this top, that is the render top. We would like to put it here, and then we use pickable flags, and then we try not to include the non-pickable objects. So, but even though in our case you only have pickable objects. Okay, the important thing is if we just use this one, and the tracking will be done by the panel. The default one is project 1, that is the whole display, and then using the panel values of UV and select. And if we want to have the custom location like this one, so we need to drag those number to here. So in that case we need to use parameter rather than panel. So the U, or I can just add a null to here. So the U will go to U, that is the X position of the mouse, and then V go to V, that's the Y position of the mouse. And then select will be here, that is the mouse click. Okay, so the movement actually will create this, and then you can also see the change over here. So we need to go to option to pick up something that we want. So we are not going to use the position, I just keep no around here, but we are also not going to use the object path, but we need to use the instant ID. So when you actually move around, that you pick different instants. So what are those instants? Those instants are the 5 spheres around here. So each of them come with one unique instance starting from 0, 1, 2, 3, 4. So -1 is the one without any selection. So that is the key thing that we want. So we're going to separate them. And so this part actually I refer or I reference the snippets here. So if you want to understand a little bit more, that one is in the render pick, yes, over here, that you can try to have a look of different types of them. So the pick custom instant, I think this one I also use, and also this one, that I refer some of the teachings around here. Okay, so let's see how we can achieve. So the first thing, we split that one, we choose the instant, and the other one we choose the pick. So when you move around, so that maybe we can have a look of the display, and then we zoom in to have a look here. That one a little bit more visible from here. And there are some parameters you can fine-tune later in order to adapt to your own lighting condition, so that is the response. So now we would like to see how we can sort out this to make it usable or useful in our interaction design. So the first thing is the instant without selection is -1, with selection starting from 0, 1, 2, 3, 4. So in that case we can do a mask to preliminary add 1 to the instant first, such that in the very beginning it starts with 0. That means no selection, and then 1, 2, 3, 4 once you have selections around. Okay, and then we're also going to multiply this one with the picked. Of course, if there's no pick, there's 0. There's nothing we would like to do unless we actually touch and pick any one of the ball. So so we multiply it. So the result of this one will be 0, 1, 2, 3, 4, and 5. And in that case, we do not want to have the one with 0. We only just want to have the one with 1, 2, 3, 4, 5, because 0 is the one with our selection. So the way to work around with this one is, so we can do a fan out. So that means the number 0 will go to the first one, 1 go to the second one, and then 3, 4, 5, 6, 7. So the channel start with 0, and then we can count 1, 2, 3, 4, 5. So we have 6 channels. So the first channel corresponding to no selection. Okay, and if you want to ignore the other, you can select the rest, or you can choose select 1, 2, 3, 4, 5, or you can choose to ignore channel 0. That's not channel 0. So now you have 1, 2, 3, 4, 5 according to your own motion. Okay, so now it's done. So you can just use this one to change the size of your selection, or to make it a little bit more useful, you can use something we call a trigger to make it less digital. So that means you have some increase and decrease in the number between 0 to 1. So we can use trigger, and then you can decide how much the attack, and then decay, and also if you would like to have the sustain or release. So I try to make it a little bit minimal to have this effect. So another important thing that we must do before we can send out this to our geometry instancing is, because we pick information from render and then process it and then send it back to geometry, and then for the render it will form a feedback loop, and in that case the TouchDesigner will flag error until you add another objects. So operators around here, so the operator is actually called feedback, to enable this kind of interaction without forming a loop in itself. Okay, so the trigger, we can do a shuffle. So the shuffle method, you can swap the channel and sample. So in that case, if you have channel 1 become 1, so they start with 1 and then drop out. And then channel 2 will be the second sample, channel 3 will be the middle one, channel 5 will be the last sample. Okay, so it moved from 0 to 1. And if you want to change the size, so you can add a mask to make sure, for example, in the very beginning, you will 1. And then there's the original size. So if you change to 1 around here, actually it will increase the size. The ball will become bigger. And then we turn to 1 after a moment. So that one you can limit size or scale. Okay, and then the rest will be, we put it back into our geometry instance. in scale, and then the scale X, scale Y, scale Z. We're going to change the size of the ball you are interacting with. Okay. The last thing, as I mentioned, is the animation or rotations. If you would like to have a rotation of the ball, you make it very, very slow. Otherwise, you're not fast enough to touch them. And then we have a mesh to put the rings. I reverse the direction like 360 to 0. And that one will go to the transform. So the rotation in this will be the Z direction. Okay, that would be a quite slow rotation, and at the same time my moving head will touch any one of the ball. So the result will be something like this. Or you can use other objects. And the fine tuning, so as I mentioned, that's one thing we use, or we actually design of our own, the thresholds around here. And then that is something that you can change to make it a little bit more sensitive and also less sensitive in a way. So if you want to make it more sensitive, you can push it to the left hand side to include more motion. And the other thing that you can also tune is in the render pick, that you can also design the size of the pickable area. So if you make it a little bit bigger, and then it will be also easier for you to pick up those locations. Okay, so this one is not that visible compared with the thresholds around here. Okay, so this is our tutorial. So in summary, so that one is our first interaction with the idea of render pick, so that we try to pick up something from the render window by providing the UV value and also the select toggle in order to simulate something like a mouse click. And then that simulation is done by picking the most bright area in the optical flow result according to your motion, and then eventually we'll use it to change the size of any one of the instant of the one of the fireball that we want to play our hand with. So that is the exercise that we try to work with. So I hope you can enjoy with this kind of interaction. Okay, stay tuned for the other creative use of the random pick in the future. Bye bye.